Introduction to Statistics, Chapter 10, Hypothesis Tests Regarding a Parameter. Section 10.3, Hypothesis Tests for a Population Mean. Recall that the best point estimate for mu, the mean of the population, is given by x bar, the mean of the sample. Hypothesis testing for the population mean mu. If we use the classical approach, this is going to be very similar to what we did when we were testing for the population proportion. You're going to determine a null and alternate hypothesis, but this time we're going to use mu instead of p. So mu, the null hypothesis will be mu equals some value mu naught. And then if it's left-tailed, we're going to use less than, right-tailed greater than, two-tailed not equal to. But this time we're going to be dealing with the mean, not the proportion. Again, we're going to select a level of confidence alpha. And that's going to either be usually 1% or 5%, sometimes 10%. But it could be different. Compute the test statistic. Now the formula is different here. Now we're looking for a t-value. So t naught is equal to x bar minus mu naught divided by s divided by the square root of n, where s is the standard deviation of the sample, n is the sample size. Sketch the curve for the test. The curve is basically going to be the same, except for now, for the critical values, we're going to use t-values. So it's going to be negative t sub alpha, it's going to be t sub alpha, negative t alpha divided by 2, t alpha divided by 2. So we're going to use the t distribution, the student distribution. Step 5, compare the test statistic with the critical value to see if the test statistic is in the critical region. Looking back at those previous drawings, if t sub naught is less than negative t alpha and we're doing a left-tailed test, that means it's over here. If it's greater than this, it's over here, you fail to reject. So we have to take this t sub naught and see, first off, know what test we're doing, and then see whether it's in the shaded region, which is the critical region, or not in the shaded region. And then step 6, write a conclusion. And again, the conclusion is basically the same. There is not enough evidence in the data at the 1%, 5%, 10%, other percent level of significance, just that from the problem. The p-value approach is very similar. Determine a null and alternate hypothesis, same thing we did before. We're using the mean. Remember, left-tailed is less than, right-tailed is greater than, two-tailed is not equal to. Okay, level of confidence. Compute the test statistic. And now this time you'd want to find the p-value for the test statistic using a table or StatCrunch. If you were going to do this, you'd probably use StatCrunch, but in the long run, when we do a hypothesis test, we're going to use StatCrunch from the get-go. So the StatCrunch will give us the test statistic, it will give us the p-value. And a left-tailed test, you're checking to see if the p-value, which is the probability, if it's a left-tailed test, probability you're less than t naught. If it's a right-tailed test, probability greater than t naught. If it's a two-tailed test, the p-value will be 2 times the probability that t is greater than the absolute value of t naught. Compare the test's p-value with alpha. Again, if p-value is less than alpha, reject the null hypothesis because that puts you in the shaded region. If the p-value is greater than alpha, fail to reject the null hypothesis. That puts you in the non-shaded region. Write a conclusion, same conclusion. There is not enough evidence in the data at the blank percent level of significance to suggest that from the problem. Now, using StatCrunch. Same thing we did last chapter. We're going to open up StatCrunch. We're going to click T-Stats, highlight one sample, click Summary or with Data. Going to enter a value for the sample mean, x bar, enter a value for the sample standard deviation, s, enter a value for the sample size, n. Click circle beside hypothesis test for mu. Enter mu naught value. Choose correct inequality sign. Less than for left-tailed, greater than for right-tailed, not equal two-tailed. Now, so looking at this, when you have a problem, you're going to need to know what the mean of the sample is, standard deviation of the sample, sample size. You're going to need to know what you're trying to compare to, mu naught. And you're going to have to know whether it's a left-tailed test, right-tailed test, or two-tailed test. And this comes from your alternate hypothesis. And then click compute. Okay, let's look at an example. Credit scores. A Fair Isaac Corporation, FICO, score is used by credit agencies such as mortgage companies and banks to assess the creditworthiness of individuals. Values range from 300 to 850, with a FICO score over 700 considered to be a quality credit risk. According to Fair Isaac Corporation, the mean FICO score is 703.5. A credit analyst wondered whether high-income individuals, incomes in excess of $100,000 per year, had higher credit scores. He obtained a random sample of 40 high-income individuals and found the sample mean credit score to be 714.2 with a standard deviation of 83.2. Conduct the appropriate test to determine if high-income individuals have higher FICO scores at the alpha equals 0.05 level of significance. So first thing we want to do is go through the problem. What is the mean of our sample? Well, x bar would be 714.2. Standard deviation of our sample would be 83.2. Size of our sample would be n equals 40. Okay, what are we comparing this to? We're comparing to 703.5. Okay, what's our level of significance? 5%, 0.05. Okay, that information. Now we want to come up with the null hypothesis, alternate hypothesis. The null hypothesis would be the mean is equal to 703.5. The alternate would be that it's greater than 703.5, because we are trying to prove up here if they have higher FICO scores. So higher means greater than. Okay, now we would go to StatCrunch. You would enter the 714.2 in for the sample mean, 83.2 for the sample standard deviation, 40 for the sample size. Make sure hypothesis test is clicked. Put 703.5 in. That automatically changes down here. We were doing greater than, so choose greater than and click compute. And here would be your answer. Now in this case, this would be your x bar, which we already knew was 714.2 because that was given in the problem. This is going to be your test statistic. You could use the graph and see whether this is in the shaded region or not according to your critical value. And of course the p-value, which is the probability. Now, we check the p-value against alpha. Well, 0.2105 greater than 0.05, so we fail to reject H naught. Okay? So that means if we fail to reject, there is not enough evidence in the data at the 5% level of significance suggests that high-income individuals have higher FICO scores than the general public. Now, when you first looked at this problem, you saw an average of 714.2 compared to the 703.5. You probably thought, yes, they are going to have higher. But when you run the hypothesis test, it's not statistically significant. So therefore, we can't state it. Just because one sample had a mean higher than 714, there are other factors that we have to check with the standard deviation, etc., which is what goes through the formulas. And that brings us to the end of 10.3. So let me go back to this problem. Let's see, it was 714.2, and let me go back one more. I guess I should just end it and go to this slide right here. So I want 714.2, 83.2. So I would go under Stat, T-Stats, one sample with summary. 714.2, 83.2, 40 was the sample size, and hypothesis test, we were looking, now you notice this is 0 down here, and this is 0. So when I put in 703.5, I think it was, 703.5 propagates down here. I was trying to prove greater than, so I choose greater than, click compute. And here is the same answer I had gotten before, with the p-value, the t-stat, and the sample mean. So that would be running through StatCrunch. And that brings us to the end of section 10.3.